All right. So, Fred, what is this Kelly Criterion?
Okay, glad you asked. Ben, what the Kelly Criterion is, it was developed by a researcher at Bell Labs in 1956. And it's a best way to allocate money to a risky asset, okay? And it really was developed the idea of betting on a gambling game, and you bet repeatedly on this game on different periods, n periods, and those could be days, weeks, years, and you're going to be betting a certain fraction of your net worth on a specific bet.
Okay, so how do you know what fraction to?
Well, that's the entire point of the Kelly criterion. So let's start with the following bet. I'm going to come up and I'm going to start with $1, and this $1 can go to 1 plus B dollars with probability W, and it can go to 1 minus A dollars with probability 1 minus W, right? So
Right. So either there's only two possibilities.
There's only two possibilities.
You either make money or you lose money.
now, in this particular case, you're going to be making money, and you're going to be making some amount B on top of your initial investment. In this case, you're going to be losing an amount A on your investment, right? So that's the setup here, right? So now the question,
Are A and B equal here? Like you could.
they are typically not equal. In many kind of common uses of Kelly, A is equal to 1, meaning you just lose all your money. But the formula can be derived, and we're going to derive this formula for general A, not just A equals 1. Okay, so now with this kind of setup, right, I want to analyze the effect of betting a constant fraction of your net worth on this game. Now,
on the Bitcoin game, or?
well, it doesn't have to be Bitcoin, right? And it could be anything. It could be the S&P 500. It could be, literally, it could be horse races. It could be you go to Vegas, etc. All these games can be modeled with the Kelly. So let's talk about a repeated bet, okay? So if you're repeating a bet, you're going to be repeating it with a constant fraction of your net worth. Why a constant fraction? Because the game is identical every single time you play it. The only thing that's different is how big is your bank account. So clearly the answer should be just a fraction of your bank account. So the question is, what fraction? What's the best fraction? Well, let's start with this idea of estimating the total revenue at some point n in the future. And this number here, the expected revenue at some point n, is going to equal 1 plus KB to the power W times n times 1 minus KA to the power 1 minus W times n. Okay, now what is that? Let's go over that specifically. KB is the amount, the K is the percentage you're going to be betting. So if I bet more, it's going to be earning B, and I'm going to win approximately W% of the time.
But how much you bet doesn't affect W.
It does not depend W. W is the same for every single bet in this analysis, right? Which we're going to get to Bitcoin. It's not the same necessarily with the power law. But let's just take a look at this. So now if we look at this and we say, great, and I'm going to need more of the board here, so I'm just going to erase this for now.
Okay.
And now what we're going to do is we're going to try to figure out how do we maximize Rn. Well, what we're going to do...
Where did you get this Rn from, though?
This is the expected revenue at time n, and it clearly has to be a multiple of how many times I won, how many times I've lost. I'm going to win W times n times on average. I'm going to lose 1 minus W times n on average. If I win, I increase by 1 plus KB. If I lose, I go by 1 minus KA. Okay, so now I need to maximize this. Well, maximizing this, I'm going to take the logarithm of this. So I'm going to take log of Rn, okay? And that's going to equal, I'm going to pull the n out. So it's going to be n times log of 1 plus kb.
Where's the W?
To the power w, right?
Okay.
Minus n times 1 minus minus n times log of 1 minus ka to the power 1 minus w, right?
Why is it
where we
minus when we had a multiplier there? Oh, because you're doing the log.
I'm sorry, plus. This is a plus,
Okay,
right?
yeah, okay, gotcha.
Okay, so that's that. So now I'm just going to take the n and I'm going to move it down there.
Cancel out the ends.
And there, the n there. So now I have this function here, right? Now I want to maximize this. And the best way to maximize this is to set the derivative of this to 0.
Okay.
Now, the derivative of log x is 1 over x, okay? So this would really be natural log, but let's just say it's 1 over x, right? So if I go here, this is 1 over 1 plus kb to the power, and then the w comes out here, and then I also get a factor b, right? And then here I get minus, and I get 1 minus ka, and I get a 1 minus w, sorry, plus 1 minus w, and I get a factor of a there. Let me just quickly check this. My notes.
So you're taking the derivative of the log function, which is 1 over x, and you're taking the exponents come out.
Yeah, this
Why
is
do you
all
have
correct.
the b? Why do you have a b and an a on the top of these fractions here?
This is the chain rule, right? So if you take the, I have to differentiate, the b is the derivative of this with respect to k is b, okay? It's like k, 2x, it's 2. It's 5x, it's 2, the 5. So this b here comes out, that's the derivative of the inside, and the derivative of this is 1 over x, right? So this is all correct, okay? So now I have to set this equal to 0, right? Oh, okay, so now let's set this thing all equal to 0. And what I'm going to do now is I'm just going to say WB over 1 plus KB equals minus 1 minus WA over 1 minus KA. Okay, great. So now I have this.
So you just flipped one half of this over to the other
I just
side.
flipped it over, and now what I'm going to do is I'm going to take this,
Mhm.
I'm going to put this there, I'm going to put this there. So I got WB
You're
times
you're
1 minus KA
multiplying. Okay.
equals 1 minus WA times 1 plus KB. Okay?
Gotcha.
Okay, let me just check. Equations. Yep,
Now
that's
you have
correct.
to distribute these.
Okay, so now we got to distribute them. So now let's pull them out. WB minus WBKA equals, and now let's pull all these things out. 1 minus WA, sorry, A minus WA times 1 plus KB, and that's equal to A plus ABK minus WA minus WAKB. And now you notice this term simplifies, right? So now we're left with WB equals
A minus WA.
plus ABK
Oh, A plus ABK minus WA.
minus WA, right? So now I'm going to take
You want to get that K.
I'm going to take the K stuff on the side. So I'm going to take ABK equals WB minus A plus WA, and that's it, right? And therefore K is equal to WB minus A plus WA over AB, right?
Right.
Okay, now we get K is equal to W over A, right? Plus, now the A's drop out, plus minus 1
Right.
plus W over B, okay? Or as we usually put it, W minus 1 over B.
over B.
So I'm going to put the W minus 1 over B.
Okay.
This here is the Kelly criterion, okay? So basically, a little bit of math, kind of advanced high school, early first year undergrad math, you can do this, okay? Now, I want to sort of show what that means in practice because...
Now let's look at Bitcoin.
Yeah, let's look at Bitcoin a little bit, and we're going to talk a little bit about kind of how this might apply or may not apply to Bitcoin, okay? Now, the problem here with Bitcoin is this. So this thing assumes I'm going to have these opportunities to have a repeat experiment every single time the experiment's exactly the same, right? In order to use the Kelly criterion, you have to allow for n experiments to be exactly the same. Now,
But Bitcoin's volatile.
well, volatile is okay. The problem is they can't change, right? Now, what we know is that a power law, right?
Graph I saw it.
So the power law says that Bitcoin in log space, right, is looking like something like this. This is a slope of 5.6. And basically Bitcoin price looks like that on a power law, right?
Yeah, but draw the upper and draw the standard deviation lines. Maybe draw a different color.
Well, this here is the log of Bitcoin price, and this is the log of time since the genesis. And it looks like that, okay? Now, the problem with this is that if you're here on the power law,
Yeah.
you have a lower expected return than if you're here on the power law, right? So you actually have a little bit of where you are relative to the trend line matters. Now, whether you're here or here, same event, right? So you see, this is not quite accurate, and that's why I really caution people. But if you do this, you can see
This is not financial advice.
this is not financial advice. But what does the Kelly criteria say you should do?
Right.
Well, roughly speaking, the power law is a slope 5.6. Okay, what does that mean? That means that Bitcoin price is roughly equal to some constant, I'm not even going to worry about what constant that is, times the time to the power 5.6. Okay, that's the formula of the Bitcoin price. Now, if this is the Bitcoin price in this year, what is the Bitcoin price in the next year? T plus 1, right? Well, this thing is going to equal A plus T plus 1 to the power 5.6, right? So if you look at the ratio of those two things, the A's drop out and you get T plus 1 over T to the power 5.6, okay? So where are we right now? Right now we're in the 15th year of Bitcoin. So if we look at the 15th year of Bitcoin, we go, what is 16 over 15 to the power of 5.6? You will find that this number is equal to 1.43, okay? And what does that mean? That means that we're on track to do about a 43% CAGR, compounded annual growth rate, on Bitcoin. Now, it also means as T gets bigger, 10 years from now, you're only going to be doing about a 30% CAGR, okay? So this is doesn't really, first of all, it doesn't work. The odds are changing with Bitcoin over time. But they're changing kind of slowly, but
that assumes a constant power law. If it ends up being an S curve, it would be different.
Right, but we do not believe that the next 10 years is going to turn into an S curve, right? So everything right now indicates that the power law is going to stay It's
Sort
going to
of.
stay a power law for at least another 10 years, okay?
Okay.
So that's kind of in general kind of what we believe.
Meaning like a straight line on that.
Yeah, so it's
Best fit
so
line.
this thing will continue like this. At some point, it may fall down, okay, and it'll collapse on the downside. Everybody's like, it's going to collapse on the upside. No. When it collapses, it's going to collapse on the downside, okay. And the reason why is instead of looking like this forever, it's going to sort of go like that, right? And this sort of beautiful exponential shape is going to turn into an S-curve. And my friend Stephen Perrinode has modeled this with a Weibull distribution, right?
Mm-hmm.
And so the great thing about the Weibull distribution is in the short term, it actually goes into a power law. Mm-hmm. So this is a likely good candidate for this kind of distribution that we're looking for. But we're looking for it at a very early point in the history of Bitcoin. Now, we're 15 years into Bitcoin. You know, this is like, imagine when we're 15 years into the actual internet, okay? You know, the internet's now been growing for really 50 years, right?
60.
You know,
yeah.
So people say the internet's only 20 years old. The web is different, right? The web started in 95, and even the web is now 30 years old, right?
Yeah.
So
Okay, so how much of our money should we put into Bitcoin?
Okay, good question. So if you're looking at Kelly, if you assume this thing was a Kelly process, the number comes out to 53%, okay? Now, is that the right number? Well, I would argue sort of no, because the following. If you believe in this process, right, you're gonna make 4x on your money in 4 years with the
Why? Because 43% compounding.
yes. So if you look at 1.43 compounded to the 4 power, just multiply it 1.43 to the 4, you get something like 4.2, right? So $1 goes up to $4.2, right? So if you have $1 million, you invest it, you're gonna get $4 million in 4 years. That's great. That is a great outcome, right? Now, what about Kelly? Kelly Criterion doesn't say the same thing. Kelly says, how about you start, instead of putting $1 million, put $500,000 into Bitcoin and put another $500,000 in cash. And, I've come up with some simple examples to show the return can actually be higher on the Bitcoin, right? So in the Kelly model, instead of getting 4 times your money, you're getting around 2.9 times your money. But you're getting almost 6 times the money on your Bitcoin. So your rate of return on Bitcoin is great.
What do you mean on your Bitcoin?
Well, you only start with...
Can you expand this a little bit?
Yeah, so what do I mean by that? So the Kelly criteria says that every year you...
So okay, let's start. Pretend the first dot is this year.
Okay, so here we are, and
or wherever,
we're
yeah.
in 2024, right? And we're right on trend line. Right now we're right on trend line. So the Kelly criteria says, great, take half your money, put it in Bitcoin. Now let's say by 2025 we've gone up 100% from today.
So we're at like 120,000.
120,000, right? What
Or
does the Kelly
130,
criteria say?
130.
HODL? No. The Kelly says you're at 50%, go down. Go down to about 40%, right?
So you sell 10%.
Yeah, sell more like 20, okay?
Okay, sell 20%.
So it'll be sell 20%. So you're going to sell there. Now, let's say you have another great year. You're going to sell another
20%.
What?
Okay, yeah, great.
So now you're going to sell another 20%. Okay?
Now it goes down. Bad.
Now it goes down. Boom. It goes all the way down to here, right? What are you going to do?
Buy.
You're going to buy 70%.
What?
Say, yeah. Well, you
already have a bunch in there.
70% of what you have. Like,
Right,
so what I'm saying.
So your value of your Bitcoin's gone down. You have more cash than Bitcoin now, but you're going to just double down.
Right. So the Kelly criteria allows you to rebalance, right? So the Kelly criteria is a little bit sell high, buy low.
Okay, so
right?
based on your math, let's just say the Bitcoin price goes up and down. You rebalance based on the price each year. Is this on January 1st of each year? Or what do you mean?
There's no really, it doesn't matter. It's just sort of saying, and even the choice of year is arbitrary, right? The choice of year does have a tax consequence, right? If you're rebalancing in anything less than a year, you're going to pay ordinary income. If you balance at once a year, you're going to pay capital.
Okay, let's just say we start at 500,000.
Mm-hmm.
Where do you end up with? You end up with 3? I'm sorry.
You end up with 1.5 million in Bitcoin. Plus you have your, I'm sorry. You end up with
You end up with
2.9 million in Bitcoin, almost. It's 2.9 million total portfolio, and you still have half your money always in cash.
So half your money's in cash. You have
At all
$2.9 million.
times,
So
right?
you start out with $1 million. You end up with 2.9 million.
But half of it's in cash.
And now, okay. And then what if you start out with $1 million? We put up 100% in Bitcoin. You have $4 million in Bitcoin.
Yeah, so you have more money in Bitcoin. So
But you have less exposure to the downtime. So
you're more efficient if you're not going completely all in. You have an opportunity to be more efficient, right?
Right.
And so that's
meaning what exactly? That
meaning your rate of return on Bitcoin is going to be better.
What's
right?
the rate of return on Bitcoin if you're half in?
Well, just it's six times, right? So in this particular case, I mean 6 times.
So the rebalancing
adds value.
Adds value because you're basically doubling down. You're kind of limiting your exposure to the down year in the good years, and then you're doubling down in the good year for the bad year for the next good year.
Now let's talk about how it potentially doesn't work. Okay.
Yeah.
So it doesn't work. Well, first reason is taxes. You're going to be paying some taxes, that's for sure, right? The second reason is you kind of need, in order to do this rebalancing, Kelly sort of doesn't want you to be more than 50% invested, right?
Mm-hmm.
Now, a lot of Bitcoiners are going to be like, screw that, man. I don't want any of that fiat garbage, okay?
Mm-hmm.
I want to be 100% invested at all times.
Mm-hmm.
Well,
except for your farm or whatever.
Right, and you're living in your citadel, growing your own vegetables, eating steak with with your hands.
With your hands, yeah.
If that's kind of your gig, well, okay, you don't believe in fiat, you want to stay away from fiat, you can, fine. But, mathematically, you can do, well, all I'm saying is you can do very, very well by being half invested, right? And so I kind of think the Kelly, what is the advantage of the Kelly? I think, if I had to sum it up, I would say the following. You may want to be less invested than you think, okay, number one. And which also gives you another advantage, which is gives you more of a buffer for non-financial reasons. So let's suppose, you get sued. Let's suppose you have a little bit too much to drink and you kill somebody or something, right? I don't know what you do, okay? Something happens to you where you need money in a hurry, right? The worst time to do it is to have to liquidate your Bitcoin in one of these horrible drops, right? You want to hodl through that period and buy more, right? If you're fully all in on Bitcoin, you can't. And in fact, you may have to sell your Bitcoin at the absolute low. So the Kelly Criterion sort of argues for, you know what, don't go all in. This is not DCAing either. It's not like you're trying to get all in. It's just like, no, I'm going to have some discipline here. I'm going to pick some number, some fraction, at which I'm going to be trying to be that fraction every year. And by the way, this is how professional money managers think. And Eric and James have made this point from Bloomberg, have made this point repeatedly, is that people in these ETFs, if the ETF does really well, yes, it'll attract many new holders and that won't be, but the existing holders will probably rebalance. They'll probably sell some of their Bitcoin because they only intended it to be 5% of their portfolio. And if it really has gone up a lot, now it's 20% of their portfolio, they're just going to automatically reduce it. Right?
What about MicroStrategy? You think they're going to rebalance?
No, unfortunately, MicroStrategy is not going to rebalance. MicroStrategy is just going to be 100% all in all the time. And, maybe that's good for MicroStrategy. Is it good for you? Maybe not, So
MicroStrategy can access more capital if they needed to.
They can potentially access a lot more capital than you can, right? And so they're in a different position. They have different instruments that are available to them.
So the big takeaway here is you might not want to go all in, and you can still do really well by rebalancing.
And rebalance just on the dot every year. Pick some day, say, okay, every calendar year, every time I'm going to do my rebalance, I'm going to wait a certain amount of time to rebalance, a certain year time. Then I'm just going to go rebalance. I'm going to say,
like June 1st every year.
June 1st every year, I'm going to rebalance, okay? And you then start taking a look at wherever Bitcoin is, and regardless of how you feel, you just rebalance.
And you take the tax hit.
And take the tax hit and move on. I think it probably does make some sense. If you're very young, if you're only going to invest 10% anyways, you got a diversified portfolio, don't worry about it. This is only if you're really, really bullish on Bitcoin. You want to go kind of all in, but potentially not go all in. So that was the Kelly Criterion. You can read more about it online. I've got a few publications, but not publications, a few spreadsheets and stuff that I've made public. And yeah, I hope you guys have understood the Kelly Criterion. It's really one of the best results in all of math that relate to financial performance. So thank you very much.
Thank you, Professor Krueger.
Thank you.